Hello, everyone. Just now, the 10 o'clock, so the start this session. Welcome to Japan and Osaka, beside Kyoto in the Gion Festival. Yeah, so you are in the new era cooperative safety. Today, we would like to share information with you in Europe and Japanese activities. We strongly wish for contribute you in the future works. I'm a chairperson at Suita. And let me introduce the vice chair is Eligast, Professor Eligast. Hi. One moment.
Yes, okay. Also, good morning from my side. My name is Rolf Eligast. I'm a director.
Please turn on stage.
It's working? Okay. So also good morning from my side. My name is Rolf Eligast. I'm director of the IFA, Institute of Occupational Safety and Health of the German Social Accident Insurance.
Thank you. Next, please. And this session composed of 3 keynote speech and 5 excellent speakers today. I'd like to express my deepest gratitude all speakers. Peers with special keynote speech in Europe trends, and then Denso and Fraunhofer will provide a keynote speech of new manufacturing as a creation and activities between Germany and Japan. Furthermore, as corporate safety activities in Japan, Toyota members will introduce their activities. FANUC, Atelier, Yaskawa, and Panasonic Automotive will introduce their comprehensive activities. So this session was driven by Eligast Sensei, Professor Eligast. So please start this session.
Yeah, thank you, Professor Suita. We have a very tight time schedule this morning, so we will start with the first keynote, and the first keynote comes from Germany. Mr. Thomas Pilz from Pilz GmbH, and Mr. Pilz will talk about safety and security for health and well-being. You have the floor.
Thank you very much for introducing me and for giving me the opportunity to speak in this wonderful conference. Let me please first introduce my family to you. My sister, Susanne Kunschert, and myself, we are the managing partners of the Pilz company, which was founded by our grandfather, then transformed by our father, and our mother, Renate Pilz, gave us the spirit of safety in digital automation. It was also our mother, Renate Pilz, who decided in 1997 that we should go and become a member of the Japanese Safety Society. We first worked very much with the MITI in order to introduce digital safety to Japan. It was the PSS 3000, the first safety PLC that we introduced. We introduced ways of risk assessment together with MITI, and we are very proud that in 2000 we were able to open up the Safety Bus P Club, which was the first digital safe field bus. We can celebrate 25th anniversary of Safety Network Japan that developed out of the Safety Bus P Club, because everybody knows it's the time of the Ethernet nowadays, and Safety Bus was based on CAN technology. Now, safety is at home in every industry. The most interesting industry, however, not in Europe, but with success here in Japan, is hydrogen as a means of powering vehicles in competition with battery electric vehicles. The promise of hydrogen is that you can use regenerable energy sources like solar, wind, or water to store the energy so that when the grid balance does not need the sun which is shining or the wind that is blowing, you can actually store the electricity rather than shutting off the windmill from the grid. Then in the storage, you can either fuel a vehicle or you can use it to create energy via replacing gas power stations into hydrogen-based power stations, giving your house warmth when it needs it. Right now, we see that the industry is scaling up, and the key to success of this key industry is the modularization. For modularization, you do need standardization. For efficiency, you do need safety, because it is the question, how long does a vehicle have to stay at the dispenser when you need to refuel your vehicle, whether it's a construction vehicle, a train, a ship, a forklift truck, a bus, or a car. Only with safety that you take from traditional industry like the ramp of a drive, you can use as monitoring the ramp of the speed of the fueling. This way you can shorten the time to having it filled up. And the next challenge we have is a trailer is an investment of around €1 million. If you have invested in a trailer, you cannot necessarily expect to have the right connections at the filling station. So sometimes they have to send the trailer away because they cannot connect. Sometimes the driver of the truck does not know which panel to connect to. Their safety technology can help to give safe access so that you don't make a mistake when you pump the hydrogen from the trailer over to the station. At the same technology you can use to provide not only the safety of the process of making hydrogen, you can also securely monitor the access. And that is a physical security measure, including a two-factor authorization methodology by which you can have remote maintenance without the danger of pirates trying to capture critical infrastructure. Because in the day of the World Wide Web, it was earlier seen as a community of people with well-thinking. Today we know that there are cyber terrorists, and every country is vulnerable in the critical infrastructure. This is why safety and security technology can help protect a country's well-being. Now, how do you combine the basic needs of safety and security with industry? We feel that it is a good decision that in Japan, well-being is in the center of everything. Well-being while at home, well-being while at work. What does protect well-being for us? It is feeling safe. Now, what makes me happy and safe when I'm at my workplace? It's the technology. Because if I am in a workplace where the technology allows me to collaborate with a very fast-moving machine without me having to be afraid that I get injured, I feel well. But safety changes. It used to be very static. You put a robot in a cage, and then there is safety. Today, You want to shake hands, not literally with a robot, but you want to share the workplace. And our esteemed colleagues will present you later how that can be done. Lately, artificial intelligence has a lot been discussed. How can that be included in safety applications, as well as industrial security? In Europe, the regulators have seen this, as well as the standard writers. We are standing in front of a big change because the machine directive was not law. The associated industrial standards were not law. So nobody could sue a company that was not interested in bringing proper safety in until an accident happened. Then the BG comes and then you're in trouble. This all changes in 2027. Then by EU regulation, you violate the law if you don't provide a safe and secure workplace, when you don't care for the well-being of your employees. What is regulated now is cyber resilience in the Cyber Resilience Act, the need to protect safety separately so that a cyber criminal cannot take over the safety function of an autonomous machine. A lot of the scenarios are around autonomous machines going haywire because they have been corrupted by cyber terrorists and they go and run into people, killing people. With proper safety technology, this is a fiction for Hollywood movies, not for reality, because safety makes sure that you come to a safe state. This again means that you need to protect the security, that you can't eliminate safety. What makes it a little bit more complicated in Europe is the NIS2 element. The NIS2 element is the German version of protecting individual data. So now your machine has to protect the individual data of the operators, which at times sounds a little bit funny that a CNC machine must protect the data of the operators that have done maintenance. But this is the European way of protecting personal data, and everybody that exports to Europe needs to make sure that when a cyber attack happens, the personal data do not get stolen, otherwise the operator gets in deep trouble. So what does that mean for the new duo, safety and security? I think it's fairly simple. A machine has mechanical hazards, and there's a risk of getting injured. Safety has the task to protect staff that wants to do their job from a machine that is programmed to do a job, and this way it is not to be accepted that somebody intentionally tries to do something bad. That all changes when security comes to place. This is when you have an intentionally malicious human trying to harm a machine in order to harm the owner of the machine. And that is what is the significant change. You now do have unexpected malicious attacks. It is not the paradigm that we have, I have an undetected failure, because the paradigm is it's always a backdoor that is undetected that the attacker uses. So if you want to use the Markov chains, you will get into an infinite loop. You can't use our math for functional safety with the probability of an accident happening for a risk assessment and the countermeasures when you do cyber security. How can modern technology mitigate and help for safety and well-being? One of the most dangerous areas is the warehouse, because you do have forklift drivers, and forklift drivers don't see around the corner. When a human walks there, it can happen that you have an accident. Also, you have the ability to regulate access in such an area when you have autonomous machines. I'm a member of the forklift truck C standards, and there we say if you close off the area where the autonomous forklifts drive, you don't need safety devices on it, but you need guarding when you enter it. So when you have such a zone, you could use a radar technology to count and detect people. You could use the pit reader technology to allow and inform how many people have put the whole area into maintenance mode, and you can ensure that they close the door behind them because the safety system will not be able to be restarted until the last key has been taken out of the electronic logout tagout pack. You still have the problem that when you have people in such an era, you want to have productivity. If you can track where the human is, you can allow full speed where the autonomous vehicle is, as long as you know that the distance is far enough so that no harm can happen. This, to me, is especially in the country of robotics. And I have to say, whenever I want to follow leading robotics, I read what's happening in Japan. You're definitely the leaders in this technology, and I hope that safety can present continuous well-being at robot applications, where security on board ensures that the AGV cannot be hacked, and where the conventional safety technologies merged with artificial intelligence and modern ways of collaborations, as you will be presented later, enable us a higher productivity with well-being in the center of the collaboration between a robot and a human. To us, security is the shield that protects productivity, and safety is the other shield that protects the well-being of a worker. I know people like humanoids. I personally think you don't really need a humanoid. You need a well-designed autonomous machine that fits the purpose. With this, I thank you for your attention, and I wish you very good presentations over the course of the day.
Thank you very much, Mr. Pilz, for this very interesting insight in safety and security technology. We have time for 1 or 2 short questions, if you immediately have some questions to the presentation issues. Is there one? If not, we later have a discussion to discuss all the presentation. Thank you again very much. So, we are going on to the keynote number 2. It's German and Japanese cooperation on collaborative safety. Mr. Kenjin Yokose, sorry for the pronunciation. You will start. You are from Denso Corporation, and the title of the keynote is The Future of Manufacturing and German-Japanese Cooperative Technology for Collaborative Safety. Mr. Yokose, you have the floor.
Thank you for giving me this opportunity. So again, my name is Kenshin Yokose, coming from Denso Corporation. I'm in charge of the factory automation business in Denso Group. So today, I'd like to introduce our activity about the safety improvement and also safety development with Fraunhofer IPA. Later, I will introduce him. So let me talk about our topics today. So next page. So first, I'd like to introduce our Denso's activity to develop the new futures manufacturing system, such as the high flexible production line. Then to realize that the safety is the most important key issues. So after my presentation, Dr. Kraus will be introducing about how solve that issue with using the digital technologies. Then finally, we like to wrap up the future issues to realizing the more safety environment in our manufacturing site. Okay, first, I'd like to introduce our DENSO's Corporation. So as you can see, some of the number of our company grants. So the first, the sales amount is almost 7 trillion yen. It's similar as the 46 billion US dollars. Then our employees, we are working with over 160 people in all over the world. Then now operating the over 30 company and territories. Then revenue ratio is almost coming from the overseas, not just the Japan side, but all over the world. Then we are focusing on the technology side also. We focus on the develop the new technologies and also new products, like as world first is our focusing the keywords. Okay. Then this chart showing our product portfolio. So historically, our main focus area was this powertrain system, such for the engine controlling unit or something like that. But as you may know, the environment of the automotive is becoming very changed now. Then EV, electrical vehicle related parts or system controlling such as the autonomous driving area is becoming bigger and bigger. So now our company is focusing on this area too. And the interesting thing is you can see these devices and also factory automation area. So to realize this business, we are developing the core technology by ourselves. So we started to develop the semiconductor devices by ourselves, and also to realize the more efficient manufacturing production system, we developed the robot or QR system by ourselves, then had to expand to the outside business. That was our history. Then this is our focus area and also our thinking way to how to contribute to the society. So this is the key words of our DENSO Corporation. So now we set the ultimate goal for the environment. One is the safety area, and also other hand is the environment area. So we set the towards zero is our ultimate goal, such as no accident in the world, not just a traffic area, but also manufacturing site also. And also eliminate the CO2 and also waste in the environment side. So today, I would like to talk about the more accident, to realizing the accident zero area. Okay, and also I'd like to introduce our initiative in the manufacturing area. So as you may know, the keyword of the lean. So lean is our base philosophy. Then we connect this lean method and the lean thinking way to the automation area also. So later I will introduce our lean automation thinking way. And to realize that lean automation, the key component was the robot. So robot productivity was important to realize that lean production system. So that's why we developed our own robot to focus on the more high speed and also more high precision and also reliability. Then now we are focusing on the more safety robot. So this chart shows the key concept of the lean automation. So as you can see, if you see the current system, you go through the Gemba and to see some of your machine, you can find out efficient area or waste of area. Then before automate the process, we usually use the lean method to apply to this current system. Then to rationalize the current system, we do in Japanese said, we 改善をして、その後自動化します。Then after rationalized the Kaizen, we developed the automation. Then we can realize the more lean automated process. Then after that, of course, continuous improvement is the key to improve their productivity. And this circular system start from the investigator system and the Kaizen, then automate and Kaizen. Such as a loop, it will be the most important key in our operation. So this is the lean automation concept. Then I'd like to talk a little bit about the before automation, how we can find the waste or muda from our current system. So below you can see this is the 7 muda. 日本語で言うと7つの無駄です。で、you can find the processing muda or transportation muda or defect muda or many muda or waste is the actual site location. Then after that, we find out and we improve and attack and many types of muda before the automation. So more detail, I'd like to show about how eliminate the muda and how to transfer that system to the automation. So left side, you can see the left and right, both sides using the same machines to assemble. But transfer system is left side is the human and the right hand is the robot. This is a quite same system. Then before automate, you can see these people is working very hardly and also very quickly. No motion, no waste of motion. Then after understand how to work as efficiently, then we apply this human motion to the robot. That is the lean automation method. So after that, you can see the many very high efficient automation system. After automate, the Kaizen activity is quite important, I said. So now currently we are using the IoT system to visualize the muda and the loss of the machine operation. Then not just finding the waste, we need to attack immediately with our Gemba side. The one team and all together is one of the key things. 日本語で言うと全員参加の改善です。で、as you can see, that activity is also very important to improve, continuous improve our processes. So anyway, to realize that system, we have been developing our robot system from the very early stages. As you can see, historically, we developed a more high accuracy robot, such as you can see the sealing system. So this was developed by 1988. So before I joined to the Denso, when I see this video, I was very impressed. So, and after that, we developed our business, such as the Denso Wave robot company. Then now we are focusing on adding the more safety function to the robot. So you can see that this is the latest, our collaborative robot. So it can works very high speedly. And the key was the actuator controlling system. Then I'd like to talk a little bit about what is the future production system. So Denso was historically focusing on the more right-hand area. So you can see this chart is the certainty of the production volume and also certainty of the product life cycle. So if you developed your component or your product, then maybe this area will be more better to make a high cost efficiency. But recently, the system need to respond to the more flexible manufacturing. So that's why we need to develop this area also. So this is the latest example, actual flexible machines example in our Denso group. So this is the concept. So you can see the conveyor system, transfer system. Then each robot module can connect to anywhere they want to make a more flexible system. So you can see the many collaborative robots can move and join to the transfer system, and we can produce the many variety of the products. No limitation of the product. Then to realize this system, the safety is the key. So if the maintenance people come into the machine side, machine will be autonomously becoming slowly. So now we are using this type of sensor system to detect the human. Then after finish the maintenance, the robot can be moved more faster. So you can see the people in here left side, and also after finish the maintenance. So this is the latest system. Then to realize that type of system, the key is the risk assessment. So this is the one of the example in our company. So when you install the collaborative robot, it takes 40 or 50 or more than 50 hours to make the risk assessment of total system. So maybe you know very well about ISO standard. So to start this activity, the determination of the limit of the machinery, and also hazard identification, and estimate the risk, and also evaluate the risk. Such kind of loop is very is needed. Then this process is very complicated and also very difficult to do just a robot engineer. So we need to learn a lot about this risk assessment. Then the issue is to takes a long time, and also need the high expertise. So that's why to realize that we need to develop some of the risk assessment tools to make it more easier and also more better. So that's why we Denso and Fraunhofer collaborate to develop the new system, such called as the CALA, computer-aided risk assessment system. So from now, I'd like to pass our mic to the Dr. Kraus. Then he will introduce our joint development activity.
Thank you. Yeah, thank you, Yoko-san, for the presentation. Also, thank you for the invitation. There's a possibility here. And my name is Werner Kraus. I'm with Fraunhofer IPA, so almost in the same city than Thomas Pilz in Stuttgart, so in the area of Mercedes, Porsche in Germany. And at Fraunhofer IPA, we are in robotics since 1973. So since more than 50 years, we are pushing the automation border. And myself, I'm responsible for the automation and robotics division at IPA, where we're around 70 people working on all kinds of industrial automation. And Denso is a long-term partner of us since almost 10 years. We are cooperating, especially in the area of robot safety, because it's really an important topic today. And what we have learned, and we have also seen it in the Denso presentation, like the sealing application, we have already seen incredible automation solutions in the past, already 20, 30 years ago. Processes were automated where we thought, okay, it's not possible to automate it because it's flexible, we have complex work pieces. And when we are looking into our history, we are seeing that we have always the same processes. So already today, we are still doing handling tasks, assembly, we are doing welding, gluing, and therefore we have said we are talking now about the automation of automation. So we are now automating all the processes around the robot system. So for example, when it comes into the process design, conception of the robot system, the engineering, okay, how do I do the layout of the robot cell, especially also the risk assessment, which is the focus today, but also self-learning bin picking, or also then also the autonomous navigation. And this will give us the possibility to also introduce automation in the area. We have high mixed low volume production, and we have also scarcity of skilled robot programmer, basically. Because today, every year, we are introducing around 600,000 new industrial robots worldwide, and every robot needs a robot program, needs a gripper, but also needs to be safe. And that's the point where we are started with our Kara. One of the enabling technologies is the so-called matrix production. So it's a production concept derived from Industry 4.0, which allows for personalized products. So we have positions in the loop which are completely manual, but then we have also fully automated stations where we can have also highly optimized robot solutions. And this combination allows us to combine the strengths of human and robots, combined and also with autonomous mobile robots, which enable for the material flow. But we have seen that safety is a really an important topic, and it's not, of course, not only nice to have, it's mandatory, and it's often also underestimated from a cost side. So around 10 to 15% of a complete robot system is invested into all the safety-related components and also the engineering efforts. And when we are looking into the worldwide robot market, it's currently around 17 billion US dollar. That's the industrial robot market. And all these robots which are sold worldwide need to be compliant towards the safety regulations. And this means out of a robot, without fence, without safety, we need to have a robot with safety systems, which is then also compliant to the safety standards. And here we see a market potential for such engineering tools in the size of more than 600 million US dollar. Looking into this market, we have two main problems. The one is that the safety costs around 15%, but it also decelerates the deployment. So with the manual safety compliance, so running to this risk assessment, we are 3 times slower in the deployment of the robots. From the challenges, we have seen already this impressive example where we have mobile robots are changing workplaces, we have changing products and variants, also hardware and software is frequently changing, and then we have also machine operators which are also changing the machine. And this means we have to ensure the CE certification when the robot is deployed, but we also have to re-evaluate the safety during operation of the robot. This means CE marking when change the place of the use of the parameters. We should re-certificate the robot after making changes, for example, changing the workpiece. But then we have to also support the engineers in performing the risk assessment. This means we have to incorporate the safety standards, like use inherent safe design, for example, check the machine borders, but also adopt the safety configuration, for example, in the PLC in the end. And then also support the engineer running to all these standards and norms which we have to take into account. This means we have quite a complex task to solve. So to come from a robot or a robot system which is doing machine tending quite well without safety to a safe system. So this means to identify the hazards, guide through the risk assessment, and then also implement these measures in the robot, in the PLC, and also write the documentation. And that's the process Cara is automating, and that's also the work, the task where Denso and IPA was collaborating in the past years. So there are a couple of engineering tools around this automation of automation when it comes to the safety ecosystem. So on the one hand side, we have a computer-aided risk assessment, Cara, so a software tool. It's like visual components, which helps us in exploring the hazards which appear and also how to mitigate them using laser scanners, for example, fences, light curtains. But then, as you know, we have then also the power and force limitation, for example, as a safety measure. In this area, we are also building up a data set using a human-robot collaboration collision testbed. So that's on the bottom left to see. This means we are identifying the actual hazard which a robot presents by doing such collisions. So we are identifying the forces from the universal robot in several arm positions with different velocities, with different end effector weights, which allows us to build up a database. And we can then ask this database about a forecast, how severe a collision with a robot will be in a certain position, with a certain workpiece, at a certain speed, at a real robot. Finally, when we are running into the risk assessment, we have typically something like robot speeds. We have some parameters regarding when the safety sensor has to switch. This means all this has to be finally deployed to the safety PLC. And here we have also an exporter. So all this nice simulation results are then transferred into Cara to set up the PLC, to even make also the validation sheets to check whether the safety PLC is working in that way, that how we expected it from an engineering perspective. And this also supports the integrator. Finally, we have a robot dashcam. As we have known, in the risk assessment, we are doing lots of assumptions. For example, assumptions, how often is actually a worker in the area of the robot, for example. So is it 1 time per hour? Is it 10 times per hour? So this is all kind of assumptions. And we have found out that in practice, the assumptions are mostly too conservative. So we expect that the human is more often at the robot, so the risk exposure is higher. And to validate this, we have a robot dashcam. So it's a bit like in the car. So we have a camera which is watching what's happening around the robot. It's detecting people, and in the end creates a report and which says, okay, at that position there's typically a worker. Here is never a worker, and this allows you to adjust your assumption in the risk assessment. And we can typically increase then productivity by 10% because we have more realistic assumption in our risk assessment. Here's a short video about Cara, which shows how Cara helps us in running more smoothly through the risk assessment by this digital twin technology. So we have really a streamlined process, starting from a robot simulation, for example, from visual components, then going into hazard identification, followed by the risk estimation, and then CARA proposes multiple safety concepts. Then the risk is re-estimated. We are checking the configuration, doing testing, CE documentation, and by following these steps, we have then the safe robot system. This reduces engineering efforts, and together with Denso, we have seen that we can reduce the efforts by more than 54%. This means we need only half of the engineering hours using CARA to have a safe robot system, and that's a really good leverage. To give you some background, we started the collaboration almost 10 years ago in 2015 with the goal to reduce safety costs by 60%, especially when it comes to collaborative robots, so fenceless robots like cobots. In 2019, we had a first concept and a prototype running, and you see here that it was also part of the development that it becomes easy. So we have the vision that you start with a robot system and you just press one button, make it safe. Then CARA investigates all hazards, checks, okay, where's the risk, how can we mitigate it, where do we place, for example, a laser scanner, where a fence, which kind of safety technologies are we using. And there has been this advanced functionality. So we are now also supporting users with limited expertise, so that also a non-safety expert is able to create a safe robot system. And this involves the automated suggestion for the choice and placement of safeguards, but also to guide through this process of estimating severity, probability of occurrence for risks. We also extended it in 2022 by the collision testing, which I mentioned earlier, and also safety PLC configuration, so that we have a complete pipeline. Today, we have a minimum viable product. We are doing beta tests with end users of robots, especially in Germany. And the future direction goes into more mobile robots like AMRs, humanoid robots, the more complex environments which are unstructured. So, for example, in warehouses or in agricultural applications where we have no digital twins available. And so this is so the pipeline for CARA itself. And we are also in the phase of preparing a startup for Robo Safety Assist, which is supported by Denso. And we expect to have the startup ready already in the course of next year, which is then a company applying a web application where you can run through this process online. And this startup will help robot end users and system integrators to make their robot safe. And so that's our plan to scale. Maybe one last insight into the safety. So in Europe, we've already heard it from Thomas Pilz, that safety is now a law, but also AI Act, for example, when it comes to artificial intelligence. And we have also created an experimentation area where we are exploring, okay, safety and AI in the area of robotics. And the AI Act is basically applicable to all AI systems. So it could be a chatbot, for example, but also autonomous car, but also a bin picking solution, but especially also a AI safety sensor. And the machine regulation applies to all machines. So it could be a robot, CNC machine. And now the question is, okay, how do we put these things together? And so when we have a system, it's the question, okay, AI system, is it a part of the machine? If it's no machine, only the AI Act applies. Then if AI is in the machine, and the question is, okay, is AI a function, for example, bin picking, or is it a safety function? When it's only a function, we have to look only in the AI Act. So when you are using, for example, AI in computer vision to detect workpieces, it's sufficient to look into the AI Act and into the requirements for software, where we are coming into the point of cybersecurity, which was mentioned earlier. If AI is also used as a safety function, so as a protection of human, but it's not continuous learning in operation. So we have a machine, a robot, which is using AI to detect people, but it has no learning on the fly. It's no high-risk assessment, but we have to look into reliability and maybe also in a third-party certification. And as a future perspective is something like a robot which is using AI to detect people in a safe way. And then we are at a high-risk system. This means this system requires also third-party certification. And so the first two, they are quite major in Europe, but using safety and AI, put these together is still a big challenge where we are strongly working on also in research projects, because I guess that's the holy grail, that we are able to use AI to detect people, to adopt the speed to have implement this kind of dynamic safety. So short summary, as we've seen that in the last decades, robots become more flexible. We have bin picking skills, for example, assembly skills, they become mobile. So robots are more flexible, and therefore we need also more flexible safety. We need dynamic safety design to also make these flexible robots safe. And we have seen that such engineering tools like Kara have a high potential to support engineers performing the risk assessment. So we can reduce the efforts by 50% and also make the deployment much faster. And we see from the vision point of view, the combination of safety and AI down the road, which is quite challenging, but here we are also building up competences. And now I would like to hand over again. Yep.
Thank you, Dr. Kraus. So let me wrap up our key message again. So first one is the manufacturing is revolutionizing over the next generation. So such as the flexible for volume and variant and reconfigurable. Then he said this kind of is a matrix production system. And safety will be more important for the human-machine collaboration. And the key will be using the more digital technology to implement that one. And also, to think about the future, zero accident, that maybe we need to more collaborate with Japan and Euro, German, or any other countries. So to realize that and also toward to that. So this is our message. So thank you for attention.
Thank you very much, both of you, for the very interesting presentation. We just were talking, you showed very short time the QR code for your Kara system, I think. Can you show it again? Then the audience can use it. That was one question. Is there another question from the audience?
すいません。プレゼンテーションの中で QR コードがちょっと出てたと思うんですけど、すごく短かったらみんな取れなかったと思うんですね。ちょっと出していただくことはできますか？
So this is our
Yeah.
LinkedIn connection. So
Yeah,
if possible.
thank you very much.
QR コード
はい
プレゼンテーションの中で出てたと思うんですよ。大きく。もう少し手前のところ。もっと前
クラウスさんの
クラウスさんのところですね。
動画ですかね。
Everyone, please prepare your cell phone. And if possible, we can accept the questions and proposal is in Japanese. Okay. 日本語でも大丈夫ですので、ご質問ある方は手を挙げてください。よろしくお願いします。
Just a short question for me. You were talking about the future aspect that you want to have a look at more complex environments. What's the technology you are using? It's motion analysis of humans and robots, or it's AI algorithm to make everything more efficient. Maybe you can tell us a little bit about it.
On the one hand side, we are using person detector like skeleton trackers, for example. Also different safety technologies or sensor technologies to make it redundant. On the other hand side, we are dealing with the point that we don't know how to specify the safety sensor. Because it's unstructured, so we don't know what's going on, and we cannot foresee all risks. And that's then also part of the research in the area of explainable AI.
Okay. Yes, there's one problem with your QR code because the document is not found. Maybe later or after the session, you can give an update. Then we got the information.
Sorry for that.
Thank you again very much for the both speakers of the second keynote. And you will continue.
No problem. Dr. Werner, please upload after this session. Hi. Next, we will present the Japanese activities. Please start your presentations from Nobuhiro-san. He's a main drive in Japanese activities, collaborative safety. Toyota has a concept and activities, Jidoka. It means the human-robot ultimate collaboration. So summaries will provide the Nobuhiro-san. じゃあ、Nobuhiro-san、よろしくお願いします。
Good morning, everyone. I'm Masaki Nobuhiro from Toyota Motor Corporation, and I'm belonging to the EXPO. I'm a chair of a Monozukuri committee of EXPO. Monozukuri means manufacturing. And please allow me to explain in the Japanese.
No problem.
No problem?
No problem.
Sorry. ちょっと日本語で話もさせてもらいます。まず私、ものづくり委員会の委員長をさせてもらってます。でも、EXPO というところをご存じない方もいらっしゃると思うので、紹介します。EXPO は、EXPO is an Institute of Global Safety Promotion, Safety Global 推進機構という機関です。2016年7月に設立されてます。The purpose、目的は協調安全、セーフティ 2.0 という 新しい安全の概念、技術の提唱及びその普及推進です。でさらに、働く人が安全で心身ともに健康に働ける環境のもと、生きがいとやりがいを持てる社会の実現というところを目的としております。そして、EXPO にはたくさんの委員会があります。EXPO has a many committee and ものづくりcommittee is one of the committee。ものづくり委員会はその中の一つの委員会という形になっております。ものづくり委員会の活動ですけれども、一つはですね、協調安全というものをものづくり現場に導入するというところを活動の目的とします。その目的としては、安全性と生産性を両立させるというところを目的にしています。さらにですね、働く人のウェルビーイングの実現を支援するというところを目的にしています。さらにもう一つですね、ルールと要求事項というところをどのようにすればですね、協調安全というのをものづくり現場に適用できるかということを考えまして、それに向けた標準化の活動というものも推進しております。で、我々のメンバーにはですね、22の製造者と使用者というところが集まっておりまして、ものづくり現場における生産性の安全性と生産性の両立に取り組んでいます。で、協調安全というところで、人と機械の人と機械が共同して作業すると、協調して安全を実現するというところなんですけども、結局のところですね、機械というのは製造者が作ると。で、実際現場ではですね、使用者がそれを使うというところで、やっぱ製造者と使用者がいかに共同して、こういう安全性と生産性を両立するかというところで、製造者も使用者も両方入っているというところがこのものづくり委員会の特徴かなというふうに考えております。で、我々の取り組んでいる課題としてはですね、製造現場では労働人口の減少とか、人中心の自動化とかいうところがありまして、それをするために、我々が目指すところというところは、共同アプリケーションというものを活用してですね、産業用ロボットとか移動ロボットとかいろいろありますけれども、それらをですね活用して、人と機械が共存し、安全性と生産性を両立する生産現場を実現したいよねというところを目的としています。ただし、実際リスクアセスメントとかをしてこれを実現しようとすると結構課題があります。皆さん参加いただいているメンバーが共通の課題として抱えているんですけども、安全策なしだと低速でしか動かせずに、生産性が低いですよと。もしくは高速で動かそうとすると、結局安全策が必要となってですね、人との共同作業ができないというところがあって、これらの課題をどのように解決すれば安全性と生産性が実現できるかというところで委員会の活動を行っております。で、ちょっとここからはですね、EXPO のものづくり委員会に参加しているメンバー企業の方々にちょっとバトンタッチをしてですね、それぞれの企業がですね、会員の方々がどのようにこの課題を解決しようとしているかというところを順番にご紹介いただきたいなというふうに思っております。はい、じゃあ続いてですね、パナクの森岡様に、バトンタッチしたいと思います。
Okay, thank you very much for your introduction. My name is Masahiro Morioka. I'm from Manak Corporation Robot Development Division. Okay, first of all, thank you very much. I'm very happy and excited to have great opportunity to have join this so important international symposium and make my presentation in this conference. Okay, I would like to introduce automation of manufacturing site with safe and secure collaborative robot. Before the main topic, briefly, let me introduce FANUC briefly. FANUC headquarters is located near Mount Fuji in Yamanashi Prefecture in Japan. As shown in this photo, I always work in this area. We FANUC have three key major products for factory automation: FA, robot, and robo machine. FA is our basic product, including CNC and sub-motor technologies, mainly used for many machine tools all over the world. And based on these basic products, CNC and sub-motor technology, we have also a robot today topic and robo machine, such as a small machining center or electric injection molding machine and so on. We manufacture all our product, FA, robot, and robo machine in our own factory only in Japan, and by using a lot of our own industrial robot manufactured robot, highly automated manufacturing in our own factory produced not only a higher productivity and cost reduction, but also a higher quality and higher reliability with no or less manual unstable operation. From now on to the topic, safe and secure collaborative robot. We are now facing a lot of challenges in the manufacturing field, as you know, such as securing labor and how to transfer skill from expert, cost reduction, and how to respond variable mix and variable volume production, and of course, energy saving, carbon neutrality is becoming more and more important, as you know. So to solve these problems, collaborative robots are indispensable from the viewpoint of automation that is flexible, simple, and reduce system cost. Again, what is collaborative robot? Collaborative robot can work together with human operators with no safety fences. Conventional industrial robots have faster speed or larger payload, and so dangerous. That's why safety fences shall be installed between robot and human operators. However, from the viewpoint of ease of installation, the traditional one might not be easy for the manual side installation. On the other hand, in case of a collaborative robot, no need for any safety fences, as you know. So, for example, right side, as shown in the A, workspace sharing can be available. In this manufacturing style, robot and human operator work separately. However, can work in the same area without any safety fences. So the combined manufacturing style can be available, such as robot to human, robot to human. And of course, collaborative operation is also available. For example, while a collaborative robot hold some heavy parts, human operator can concentrate on executing some complicated assembly operation. We have a lot of collaborative robot lineup as shown in this slide. We call CRX series with ease of use even for first-time robot users. Of course, as a collaborative robot, the first priority is safety. However, this collaborative robot CRX has three key features: not only safety, but also ease of use and high reliability. Okay, from now on, please see this introduction video. CRX robot has been installed for various applications. Of course, this robot has good safety function like this contacts of function, so safe and easy to operate by direct teaching, manual guided teach, and furthermore, easy to make a program by dragging and drop icons on the tablet pendant. And again, CRX robot have been installed for various applications such as arc welding. CRX on the handcart is very useful. And mobile platform available, and power input, standard 100 or 120 volt input available, so easy to install. Of course, high reliability, more than 8 years, no change of robot parts, maintenance free. So available for various applications, logistics, painting, and machine tending. We have a lot of collaborated robot lineup as shown, from a payload of 5 kg to the maximum 30 kg. From now on, I want to show just one details application for easy installation with a handcart. CRX collaborated robot is so lightweight. That's why CRX collaborated robot can be used on an AGV or a handcart. So very easy to install when and where a customer need. This application shows the machine tending. Firstly, CRX on the handcart is set roughly in front of machine tool. As you image at this moment, some position gap might be occurred between the machine tool and the robot. So by using our own vision system, robot can compensate the position error. So robot can work so precisely. From now on, after picking up machining parts, and from now on, opening the manual door like human being, and finally, the robot install the workpiece into the machine tool. So as you see in this video, collaborated robot can be installed with any safety fences, and robot can work the same operation as human operator, such as pushing some buttons or opening or closing the manual door and so on. So collaborated robot can easily be installed in the manual side in the same devices, peripheral devices as for human operators. That means no need for change for robot installation. So that's why very easy to install. Final slide, safety and well-being with collaborated robot. Here is comparison between human operators and conventional industrial robot. The left side, in case of human operation, some hazardous tasks such as heavy parts handling or operation in the hazardous, severe, dusty or chemical environment might result in the risk of industrial accident. On the other hand, right side, in case of conventional industrial robot, of course, as you know, they are very useful and helpful for automation. However, conventional one need safety fences. So customer need to investigate some cost or space or time to install. On the other hand, in case of collaborated robot, as I mentioned, without any safety fences, so robot can be easily installed in the manual side without any safety fences. So hazardous tasks such as parts, heavy parts handling can be easily automated. So resulting in zero industrial accident. That's why safety and well-being can be realized by using collaborative robot.
Okay, that's all for my presentation. Thank you very much for your attention.
Thank you very much, Morioka-san. Let me introduce your personal introduction. Morioka-san is the main driver to develop the collaborative robot and great activities in the commercially. Very impressive, your presentation. Thank you very much.
Thank you.
Next presenter is Daichi Mizoguchi, President of Atelier Corporation. He is present for the signal-based approach to collaborate safety, technology trends, and standardization respects. So please, make a presentation.
Thank you. Thank you for the introduction. Good morning, everyone. I'm Daichi Mizoguchi from Atelier Corporation. It's my honor to be here to make this presentation. And at Atelier company, we work on functional safety consultancy and cybersecurity consultancy, as well as supporting international standardization. So today, my title is signage-based approach to collaborative safety, technological trends, and standardization prospects. Okay. So let me read my cheating papers. Okay, so number one, collaborative safety and signage. So as the previous speakers already mentioned, collaborative safety means people, machines, and the environment work together to keep safety and productivity. And some standards already requires that people can predict machine movement and avoid it safely or work together. And here, signage plays a key role. It uses visual, auditory, and even tactile cues to communicate machine states and guide people to act safely. So, number two. Three modalities of signage and standards. So, some standards already established for signage design. For visual, for ISO 1148, specifies some colors and blinking patterns. And for sound, ISO 7731 defines frequency range and sound levels. And for tactile signals, ISO 9241 and SAJ 3280. This is not international standard, but guideline for automotive industry. Sorry. So they recommend vibration strength and quick response, ideally within 100 milliseconds. So combining these signage modalities helps, like visuals show status, sound grabs attentions, and vibration promotes immediate action. So following these standards is essential for reliable and safe communication. Number 3, research trends and gaps in standardization. So on the other hand, academic research is moving ahead with advanced methods. For example, AR is used to display dynamic signs in the workplace, and AI adjusts sound or vibration depending on the situation. And some tactile technologies guide people to safe directions through vibration patterns. However, current standards focuses on fixed colors and fixed sounds, and guidelines for encouraging behavior change or integrating multiple modalities are still missing. And this is I think it's a big gap between current standards and current research trends. So last year, we have already conducted an experimental study. We tested the effects of combining light and sound. So in a setup environment, workers played assembly tasks while reacting to the signals. And the combination of light and sound was easier to notice and caused fewer mistakes than light alone. And some combinations of light and sounds were especially well accepted as they were noticeable. So this shows signage can not only show information, but also actively guide human actions. Number 5, future direction of standardization. So future standards need to include advanced technologies like AR and AI can provide adaptive and dynamic signage depending on the situation. And also we need better evaluation methods like eye tracking or physiological measurements to consider human workload and reaction speed. And we also need to organize how to combine modalities like visual, auditory, and tactile signals, depending on different work environment. Key points. First, so signage is evolving from simple warning tool to interface that helps people understand the situation and choose the right action, safe action. And second, importance of evidence. So its effectiveness, faster reactions and fewer errors is a key issue. So standardization should be based on proven data, such as faster reaction and fewer errors. And finally, we need to standardize we need to standardize signage design using advanced technologies such as AI and AR and multimodal integration to support human perception and actions to advance collaborative safety. Thank you very much for your attention.
Thank you very much, Ms. Guchi Daichi. Your presentation is very impressive for the current activities and future activities for the standardization. Thank you very much.
Thank you very much.
And the next speaker is Takashi Nishimura. He will present the next generation manufacturing based on data with iCube Mechatronics. It's a platform for our future works to the collaborative safety. So please start your presentation.
Good morning, everyone. My name is Takashi Nishimura from Yasukawa Electric Corporation. Today, I'd like to introduce about next generation manufacturing based on data with iCube Mechatronics. First of all, I'm sorry, but I don't prepare English script. So from now, I'd like to speak in Japanese. Sorry. はい。はじめに、安川電機の、プロフィールと事業の簡単な紹介です。弊社は、1915年に、創立して、今年で110年を迎えて、現在はモーションコントロール、ロボット、システムエンジニアリングを主な事業としております。こちらは、弊社の事業の変遷です。1915年に石炭の搬送という、世の中で重要で人にとって危険な作業を電動機により電動化したところから事業が始まっておりまして、ここからモーターで事をなすというところが始まりました。その石炭搬送の電動機からメカトロニクス分野にシフトし、プロセスオートメーションからファクトリーオートメーションまで貢献の場を広めています。1977年には日本初の全電気式の産業用ロボットを開発し、世の中の事の発展をリードしてきております。で、その前の1970年に、理想のモーター工場としてアンマンドファクトリー構想を描いています。これがアンマンドファクトリー構想で、理想のモーター工場として、1970年に描いた概念図です。各工程は、コンピュータ制御され、全体は通信で結ばれています。この工場の構想はノーマン、すなわち完全な無人化ではなく、人手依存を脱しつつ、人間中心でいわゆるウェルビーイングな、自動化工場をイメージしたものです。戻りますが、このアンマンドファクトリーの実現を描きつつ、用途最適化の産業用ロボット、食品向けの機器など自動化を実現するための多様な製品を開発してまいりました。そして現在、ものづくりをさらに進化させるiCubeメカトロニクスというコンセプトを提唱して推進しています。iCubeメカトロニクスとは、新たな産業自動化革命を実現するデータ活用によりメカトロニクスを進化させる安川電機のソリューションコンセプトです。この iCube メカトロニクスの3つの I はインテグレイティッド、インテリジェント、イノベーティブを意味しています。これは iCube メカトロニクスが実現された工場の概念図です。ものづくりの自動化において生産現場のコンポーネント、例えばロボットと周辺機器、上位制御装置を統合することで各機器をつなげるためのデータが生まれ、生産現場全体がデータでつながります。これがインテグレイティッド。そしてここで生まれたデータを収集・解析を行い、生産現場において生産の分析や作業の学習に活用することで 生産のノウハウが生まれます。これがインテリジェント。そして、この結果を生産に活用することで、データに基づき生産現場が最適化され、生産性が向上されます。これがイノベーティブ。このように生産現場を統合することで生まれるデータを軸としたファクトリーオートメーション。これが、iCube メカトロニクスのコンセプトです。この iCube メカトロニクスの実現により、生産現場は自動化され、デジタル化され、生まれたデータを活用することで生産性の向上の価値が生まれます。この生産現場の自動化により、人に頼らない持続可能な生産体制を構築できるという価値が現場に生まれます。しかし、データを中心とした自動化の価値は、この省人化ということだけではありません。生産現場のデジタル化により、生産現場が正確に見えるようになります。そして、ここで生まれたデータを活用することで、生産現場にさらなる付加価値が生まれます。例えば、食器の洗浄作業の自動化を例に、データの活用の一例を説明します。食器の洗浄作業をロボットにより自動化することで、廃棄物のデータが集まります。この廃棄物のデータを収集して分析することで、例えばどの種類のものがどれくらい残されているのか、それらが季節、気温に相関がないか分析できます。この分析結果を参照して新しいメニューに展開するということをすることで、フードロスの低減につながる可能性が生まれます。あるいは、洗浄作業においてデータをもとに分析することで、水や電気などのエネルギーロスの低減が可能になるかもしれません。これらは、一例に過ぎません。現場のデジタル化によって自動化に対する付加価値がさらに高まることが期待できます。また、データの活用により自動化領域の拡大も期待できます。既存の自動化領域である自動車産業の発展、自動化においては、用途最適化ロボットが大いに貢献していました。この分野は高い繰り返し精度を持って、かつ高速に実行するロボットが要求されており、決められた作業を決められた通りで実行することで、ことが実現できていました。しかし、これだけでは自動化ができる分野は限られており、まだ自動化が進んでいない未自動化領域が多く存在しているのが事実です。この未自動化領域は、環境の変化や作業の不確定要素が多く存在しており、作業の難易度が高く、自動化の障壁となっています。ここの自動化には、状況を認識して、状況に応じて判断するロバスト性、フレキシビリティ、そして人との協調性を持つことが必要であり、ロボットは作業力と判断力を兼ね備えた自律性、オートノマスロボットが必要です。そこにはデータの活用が必然となります。この変化や不確定要素が多い現場に自律性を持ったロボットを活用するにはデータと学習が必要です。現場に生じる変化に対して従来のティーチングプレイバック方式では対応しきれません。人と同じようにその状況を認識し判断し、判断に基づいて動作を実行させなければなりません。そのためには状態を認識するセンサーと判断するための AI、そして行動するロボット、これらがデータを中心として認識、判断、行動のループを実行していきます。その結果、AI モデルはデータを蓄積し、学習により進化していきます。しかし、これを実環境でデータを収集して、学習して検証するとなると、時間も場所も人も多く要します。フィールドにおいて検証する環境が足りないという状況に陥ることが予想されます。そこでシミュレーターというバーチャルの環境の活用が必要不可欠になります。そしてバーチャルと実環境のデジタルツインがここで活かされます。このデジタルツインにおいて リアル環境がデジタル化されていることで、データを軸としてリアルとバーチャルが一致します。それにより、リアル環境の状況をバーチャル環境に反映し、バーチャル環境でモーションを生成して検証まで行います。バーチャル環境で生成したモーションをリアル環境のロボットで実行することで、またデータが生まれ、また評価をして学習をして最適な動作を生成していきます。このように現場がデジタル化され、生産現場のバーチャルでの計画とリアルでの実行の連動性が高まることで、変化や不確定要素が多く自動化ができなかった分野の自動化が実現できます。以上のように生産現場のデータを中心とした自動化は、省人化、生産性の向上という問題解決でなく、ことの実現の範囲を広げて、必要な時に必要なことを実行させるようなことができる、サスティナブルなソリューションを築くことができると確信しています。データを軸としたバーチャルとリアルのデジタルツインを活用し、自動化、デジタル化によるデータを軸としたものづくりへのシフトにより、サスティナブルかつウェルビーイングで人とロボットがよりよく共存ができる社会が実現できると考えております。ご清聴ありがとうございました。
Thank you very much, Takashi Nishimura. It's a very important technology for the platform to achieving the collaborative safety and with using the collaborative robot systems. Thank you very much. And thank you very much. Thank you for the celebration from the FANAC to Yasukawa. So the final speech is Takanori Kikuchi. He is presented the introduction of the Panasonic Automotive Systems Collaborative Safety and Health Initiative. Thank you very much. So please start presentation.
Okay. Hello, everyone. My name is Takanori Kikuchi from Panasonic Automotive Systems. This is a final presentation in this section, so you might be slightly tired. Please relax to hear my presentation. And at first, thank you very much for giving us the opportunity today. My presentation theme is Introduction of Past Collaborative Safety and Health Initiatives. Here is today's agenda. At first, I will give you a brief introduction about our company. And next, I will introduce our concept for realizing well-being. Specifically, I will introduce two aspects. One is health management, the other is collaborative safety. At first, our company profile. We first create new mobility experiences to enrich people's lives by leveraging the Panasonic Group's extensive expertise in home appliances and digital AV. And we operate 9 countries, and we have 14 domestic offices. And employees are approximately 21,000. Additionally, since December 2024, we have transitioned to new management structure with Apollo. Next, our mission, vision, value, and slogan. Our mission is create a sustainable mobility society to promote a better life for everyone. And we aim to achieve the Joint Emotion Design Company. Regarding Joint Emotion Design, we are working on 6 initiatives as shown here. 1, providing safety for all car occupants. 2, redefining the cars as blissful spaces. 3, expanding the potential of cars. 4, digitalizing for smarter mobility. 5, energizing communities through mobility. 6, exploring future joint in motion. There are our main products. We are manufacturing mainly cockpit integrated solution and wireless charging systems and HUD heads-up displays and full display meters and vehicle camera module and so on. From next page, I will introduce our concept for realizing well-being. Before introducing our initiatives, I'd like to share on background and environment. The left graph shows that the working age population of Japan. It shows that the working age population will decrease by 15% by 2035 and 25% by 2045 compared to 2020. And the right graph shows that the age distribution of past employees. As you can see, 75% of our employees are aged 40 or above. From these points, we see that labor shortages are becoming increasingly severe in manufacturing, and health management aspect is concerned about the lost productivity due to the high number of age groups with health issues. So, against this background, we are working toward well-being by promoting the health management practices that ensure the health of all employees, and building workplaces that are safe and security through collaborative safety initiatives. The following will detail our specific efforts in each part. Regarding health management, this table shows our health management strategy map. We aim to improve our organization performance and medium to long-term corporate value through various health initiatives, investments. Next, these charts show that analysis result of Panasonic Group's health data. Based on these results, we encourage the practice of a number of appropriate lifestyle habits and promote them in an integrated manner with health management initiatives that enhance job satisfaction and performance. From next page, I will introduce about collaborative safety initiatives. At first, our current status and direction of past manufacturing site. We operate our businesses with safety as our #1 priority, but occupational accidents have not reached zero. Also, our manufacturing processes automation is under progressing, but some processes still rely on human operations. So we are focusing on collaborative robots that help assist and complement human work, and we are challenging both safety and productivity, and aim to free people from the simple, hard, and caring work. However, there are some challenges in implementing these initiatives. First, psychological stress. When a machine is moving close to operators, even if they know it will stop, it scares them psychologically and stresses them out. It means operators cannot feel safe. Second, safety distance. In many cases, it is difficult to ensure an appropriate safety distance. So, we are forced to operate in a way that is covered by safety fence. Third, rules, especially risk assessment. Our risk assessment and the other rules in operation at the manufacturing site are structured on the machine safety by isolation basis. last one is cost effectiveness. We cannot spend too much money, so we need to think in terms of the cost effectiveness and overall optimization. So to resolve these issues, we focus on people once again. For example, what kind of information is needed for people to recognize danger? How can we make the unconscious conscious? When do people do dangerous work? So we are challenging to create productive solutions through implementing risk assessment based on the deeper understanding of people's characteristics and conditions from the user's point of view. Then we develop the solution to operate without safety fences, and we build the environment to experience Gemba in-house. Next, I will introduce our current verification status. The left video is show that demonstration about the robot's deceleration was stopping by the combination of human detection and safety devices. Detection flow is that detect human, then decelerate or stop depending on the distance, and notifies people with color on the sound. Although still developing, we are exploring possibilities with combination of existing equipment as shown in video. Specifically, using 2D cameras and safety laser scanners for detecting people and providing visual or auditory alerts like sound and color cues to help workers. We plan to continue updating these systems. So this is the last page. Summary. In order to achieve well-being, it is important to balance to the following two. Workers in the Gemba must be healthy, both physically and mentally. Working environment are safe and secure. Average performance is higher when combined with proper lifestyle habits, and even higher when the job satisfaction is high. We are exploring to develop production solutions that focus on people in order to realize collaborative safety. We would like to contribute to the realization of the better life for each individual and the well-being of workers through our products by building and constantly improving Gemba, where valuable workers can work cheerfully, energetically, and vigorously. Thank you for your attention.
Thank you very much, Takanori Kikuchi. It's a very impressive as a practical application to collaborative robot system. Thank you very much.
Thank you.
And all speakers finished, but final presentation, including the practical approaches collaborate robot system. There is an exhibition in the first floor. Sorry, in Japanese. 信弘さん、1階で協調安全のいわゆるデモンストレーションをしているゾーンがありますよね。それのちょっと紹介を日本語でも結構ですのでしていただけますか。お願いします。はい。So, concluding by the Nobuhiro-san. So, please explain.
今日はものづくり委員会に参加しているメンバー系の方からも紹介いただきましたけども、マニファクチャリング側、製造者側とユーザー側が手を取りながら生産性と安全性両立するための活動というものをしています。で実際これまでにはですね、トヨタが協調安全の実証用のガイドラインというのを過去にEXPOの協力のもと作っております。でこれを一旦共有してですね、今課題の、実証とか課題の洗い出しとかいうことをやってきました。でさらにその内容をですね、一般化しまして、今はですね、 日本帰国協会と連携して、原案の申し出団体として、GISHWの企画を日本のユーザー機械メーカー、工業界の皆様とともに作ろうという活動をしております。これは、設計者と、マニュファクチャー、製造者側と、ユーザー側がどのように連携して、連携すればコラボラティブセーフティ、協調安全を実現できるかという観点の企画を今作ろうとしております。で、それをですね、さらに将来的には、国際規格にもできればいいなというふうなところを目指して活動をしております。こういう標準化をすることでですね、世界中のものづくり現場の人々の安全健康ウェルビーイングに貢献できるかなというふうに思っております。で、先ほど菊池さんが、協調安全の実証をこういう形でやってますよというのを見せてくださいましたけれども、ものづくり委員会としてもですね、ファナック様のロボットや安川さんのロボットを設置していただいてですね、こういう形で協調安全というのが実現できるんじゃないかというようなデモの展示をですね、このインテックス大阪の1階の展示コーナーでやっておりますので、そちらもぜひ見ていただけたらなと思いますので、はい、ぜひよろしくお願いいたします。
ありがとうございます。Thank you very much. And additional explanation. Such exhibition presented by not only the sequential collaboration, moreover the responsible collaboration with real time to the human and robot. So please go down to the first floor exhibition areas. And Pilots and Fraunhofer has a special corner in the exhibition. So please go to the exhibition areas. So the all speakers finished. のぶりさん、OK です。ありがとうございます。拍手でよろしくお願いします。So thank you very much. All speakers, keynote speakers, we have finished all session, this sessions. So the finally concluding remarks, present the co-chairs. Rolf, please finish this session.
Yeah, thank you, Mr. Suita. Well, what we learned today is that the collaborative of robots and humans are getting more and more complex. And with the complexity, there are many solutions. Also, the complexity of the safety and security also increases. And I think the application showed the sixth presentation that there is a lot of activities going on, going into standardization. And someone of you said we need data-driven or proved results to have very good standards, and then we can improve the systems. And AI, I think, is a very is in everyone's mind, because that's the next step. If we have more complex technology, we need more complex security and safety solutions.
Thank you very much, Professor Rolf. And we have just 5 minutes remaining before lunch. So please, all speakers, keep 5 minutes and change name card and discussions. Thank you very much. Thank you very much, everyone. And celebrate the all speakers. それではこれで会を終了いたします。スピーカーの皆さんはしばらくいていただいて、ご挨拶とかですね、お話しされる方はお願いします。日本の方はすいません。今日の午後、明日もセッションが続きますので、ぜひですね、ご療養、あとお友達ですね、連れてきていただければと思います。展示会の方も見に行っていってください。よろしくお願いします。どうもお疲れ様でした。